Welcome to Season 7 of the Prosthetics and Orthotics podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day.
Hi everyone, my name is Joris Peels, and this is another episode of the Prosthetics and Orthotics podcast with Brent Wright. How you doing, Brent?
You almost called me by the other guy, didn't you? Max would be proud.
I know. I'm always trying to figure out who everyone is. So you surprised me. I see the name, of course, in the podcasting app we're using, but I'm like, so yeah, I almost called you Ben, right? Because that's the guest, but I don't know very much about. I don't know anything about Ben. I think so. So that's the exciting bit. So I did almost. You called me there.
That's awesome. Well, I had a question for you, Joris. Lots of news in the additive manufacturing space, right?
Yep.
This week. What is your take on all this? Is it just a correction? I mean, I know you've written the articles and such, but these seem like big news type of things. But then you've got some of the realities that are setting in, and I think that's going to be a springboard into what the future truly looks like.
No, it's just. I don't know. I think there's a couple of big news items that are happening, and it all has to do with financing. It all has to do with people having set off on a journey more optimistically than they thought it was going to be, and running out of cash. People going through this whole SPAC thing, which is ballooned in valuations and is now coming down, and startups that were valued very aggressively, and now everybody kind of not seeing the stars in their eyes anymore. So it's just a gradual kind of reduction in expectation and a reduction in the availability of cash. We went through a period when there's the easiest money the world has almost ever seen, and then we saw people getting for essentially half-assed ideas. We're getting millions and tens of millions. I remember a friend of mine raised $750,000. I was like, only $750,000? Like, oh, it was like the whole. I was like, oh, really? Why would you want that little money? It's like, and you're like, why don't you go for 10 million? It's much better, And it was just, it kind of, in retrospect, was, far too optimistic. And it's a game of musical chairs, right? If you keep dancing, and the music keeps playing, you're doing great, right? But if you're still dancing when the music stops, then you look foolish, and that's what happened. So I don't think anybody really executed poorly. It's just that some people were really careful, battened down the hatches, fired people, stopped spending money, and these guys are better than the people that were just hell bent on growth and really tried to grow their way out of the problem.
So who wins, though? I mean, I think that's the real question. I mean, because a lot of these companies that had the cash and stuff, I mean, they were pushing some innovation. And now with this kind of, I would say even almost like a retraction a little bit. I mean, how do you win in this this environment?
I think, if you're a company right now, I think everybody now is doing from 3D systems on down. Let's say everyone's doing the same strategy, right? So, or same general guidelines. They're reducing capex, they're reducing headcount, they're reducing spending, they're focusing on protection of margins, or focusing on generating cash and conserving cash, and everybody's being more conservative, which essentially will mean that let's say it's incorrect to call it a contraction, but let's say our little speck of the world will contract, right? The business we do with ourselves will grow less, right?
Right.
Meanwhile, we're seeing a lot of things that are happening, especially in the defense world, especially on this friendshoring world, supply chain resilience. The U.S. military spent, I think it's about $7 billion this year digitizing a lot of its assets, and that's a near 3D printing kind of move. But there's so much money and so much things happening in this in the general supply chain world that and then also in satellites and new space and orthopedics. These things will continue to grow. So it's be in the right niche is, I think, a wonderful thing to say in retrospect. And to grow with where the market opportunities are, and to have a true value proposition. that really makes sense. Because, and I've said this before, like a lot of cases 3D printing is in the friend zone. Like a large corporate will be like, oh, that's a cool technology, that's nice. We should look at that, but it's not like a critical kind of like, oh my God, we need to save the company kind of technology, or we need to do this because everyone in the world's doing it. And we don't want to be the last ones left out. So if you're in these applications, these companies where you're essentially in the friend zone, then you're going to have a really hard time in a really contracting market. Meanwhile, if we're in a business where you save people money, you save people time, you allow them to play in markets they can't normally, then you're in a much, much better place, much healthier place. Like orthopedics for me is like, it's completely independent of a lot of the business cycle stuff. And if an individual orthopedics office or a chain could just save a ton of man hour they don't have, a ton of people they don't have, and money by adopting 3D printing, that'll continue, right? That had nothing to do with like the economy or something like that. They'll find it maybe a little bit more, they'll pay a little bit more for that lease of that machine, but still the economic reality of 3D printing still makes a lot of sense for them. And I think that those are the cases that really work. And I think also to me, what works is an application focused approach. So a really very focused company that focuses on unlocking one application in a really, really efficient way using additive. And that I think will continue to grow as well.
Wow. That's a hot take from Joris. I appreciate that. That's and that's good, and it's especially very very applicable to as people in the O&P space are looking towards 3D printing technology. I think they look towards some of this, and the reality is creating these applications is hard. Repeatable applications is hard, and it's just not an easy button. So yeah.
No, exactly. Yeah. You have to have a very deep understanding, but then again, you don't want to adopt a lot of the groupthink the other guys are adopting, because then you can't really innovate.
Yeah.
But you have to understand where you play, but you don't want to be too focused on it where you can't see where the real opportunities are, where there are other opportunities. And you have to really understand your additive technology, where it can play, but not too much, because otherwise you'll be too limited by what's now possible and not working towards a future where you could maybe unlock billion-dollar markets with incremental changes. So it's it's like I'm trying to come up with a methodology for developing 3D printing applications. I've been doing this for over a decade, or a bit longer now. But I'd love for there to be like 10 rules, and then ta-da, it isn't like that. It's really, really hard.
So thank you to Coyote for sponsoring this episode. And also Coyote is a company that makes lots and lots of really innovative products for prosthetics. And one of them is, we talked about one of their locking systems as well. And there's another one called the Easy Off Lock. What does this do, Brent?
Yeah, I love the Easy Off Lock. So a lot of people are familiar with the airlock. It's very similar to the airlock, but instead of you having to hold a button and you have to continue to hold a button to release the leg off, or to release the prosthesis off your leg, you can actually flip this switch, and that opens it up, and then you don't have to like hold it open or anything. You just slide it off. And one of the neat things that you can do with this lock that you can't do with the airlock is that you can add elevated vacuum or go subatmospheric. So think about like, taking a vacuum cleaner and hooking it up to a prosthesis, and the socket actually almost like sucks to the leg itself. You get really good suspension, good connection to the prosthesis. You can do that with the Easy Off Lock. One of my best memories of these are people that have hand dexterity issues or flexibility issues. So instead of needing to push a button, they just flip the lock open, and they can take the prosthesis off without a problem.
Well, that sounds really great. It's really, really good for patients as well. Okay. So head over to Coyote, check them out. And thanks to Coyote for sponsoring us.
Yeah. Well, I'm really looking forward to our next guest, and I think he'll probably be able to provide some insight as well into this. We've got Ben Demuth on the podcast today. He is the 3D marketing strategy and planning, as well as the incubation lead for HP. And I actually got to meet him in person at the last trade show, and we had a good time, a good chat. But we've known each other for a little while, and I've just always been really, pleased with what he's been up to. He is also part of the Arise team as well, and we might be able to hit on some of that. But I'm really excited just to get his perspective, from a higher level, and then maybe talk about some of the stuff as we trickle down into the orthotic and prosthetic realm. So I'm really excited about this conversation. I think you'll have a good time too, Joris.
Yeah, totally. So welcome to the show, Ben.
Yeah, thanks for having me.
So when did you first come in contact? Well, first I was asking, when did you first come in contact with 3D printing?
Well, so the shortest version is I worked at a company that was acquired by Stratasys. Right around the time that they were kind of on a buying spree. I think you might remember they bought MakerBot. We were acquired around that time, and they had been one of our customers for years, maybe 4 or 5 years. And the company was doing materials development, in short. So their acquisition really enabled them to take their materials development internally and grow their materials portfolio. So we became essentially responsible for all things materials at Stratasys on their FDM platforms. Took a couple years for the team to sort of transition fully into the core, if you will. But after about a year or two, I mean, we were off and running on new material commercialization for them, process improvement, cost improvement. And we even had a really fun program that not many people knew about, which was a custom materials program. So you may know that Stratasys hardware was and sort of still is locked down. And so we had quite a few customers that would come to us and ask, I want to do this thing that's not possible. Will you help enable me to do it? And so we ended up in a lot of really fun projects and unique applications, especially in aero and defense, where we were making bespoke materials, getting them good enough to print, and then handing them over to customers, and they were doing some really cool stuff with it. So I think it's been about 10 years, maybe more.
Okay, so that was Interface, right? Or Interface Solutions, or with those guys, right?
Yeah, yep. Interface Solutions, small business in River Falls, Wisconsin. I think we had about 30 people, and basically, if your product, had polymer or was made of polymers, we could probably help you. It was a pretty cool group, really fast iteration cycles, full service analytical and characterization labs, compounding, extrusion, bank of really smart, talented chemists. It was a really good team.
Okay, that's cool. Then I think it's a really nice opportunity then, given your background there, especially in the custom materials realm, talk about materials, because especially for O&P, people are always looking for watertight, soft, skin contact approved, but tough, that kind of thing. Okay, so first off, why is there a limitation in 3D printing materials? Is it chemistry? Is it physics? Is it the price? Why do we have so relatively few materials compared to CNC and all this other stuff?
Yeah, I mean that's the question everybody asks, right? I think the reality is it's hard. It's hard to do. It's hard to develop a material that might seem ubiquitous in something like injection molding or even CNC and milling, but to bring it through multiple thermal processes, at least in FDM, get it onto a printer, have it printing 99% of the time, and have a usable part come out the other side is very difficult. And I think people underestimate, because they think about the thing that comes out the other side, but it's the thing and the way the thing is made, right? And the way the thing is made is usually the hardest part to figure out. It's pretty easy to do a new material that kind of works, and our lab was a testament to that. I mean, we had racks and racks and racks of these experimental materials, but I would say to get from a new formulation onto a printable version of that, it was probably 100 iterations or more, depending on the material. And then I think there's this sort of paradox where materials that are easy to injection mold are often not easy to 3D print, within reason, but sparing you the sort of technical thermodynamics explanation for it. You often will find people asking for materials that are super common in injection molding, like propylene, that are really, really challenging to print. One of the things that I struggled through a lot in that role at Stratasys is I would have customers coming and asking for materials that they use every day in injection molding. And we would always try to reframe it into, well, what does that material have to do for you? What's the performance you expect? And sometimes, more often than not, they didn't actually care about the performance because they had an established rules of thumb and engineering guidance and design guidance around a particular material, and it was too much of a challenge for them to move away from that. And I think that's what's driving this constant ask for materials that aren't presently in many 3D printing portfolios. But I think the reality is it's just hard. It's really hard to do.
Yeah. But what would you advise a company like that they can't really have their material? Because there's a couple of ways about it. You could get an analogous material, whatever comes closest, right? You could struggle and try to say, hey, with that one grade of polypropylene you get from Covestro, we'll keep doing it, or polycarbonate or whatever. Or you could, come up with something new that gives you the best performance. So think, what kind of path would you suggest to people?
Yeah, I don't think there's a right way to do it. And I think what you're describing is part of the reason that 3D printing and additive manufacturing have been limited in their growth, at least relative to expectations. I don't know that it's realistic to expect every material you can get for injection molding or thermoforming or whatever to show up on a 3D printer. And I think oftentimes all of these quick off the cuff responses of, well, redesign your part or redesign your process are really impractical. And maybe the reality is there's just applications for which additive will never work. And part of that is material limitation. I think the other piece here that's driving some of what you see in the market is the cost, right? And it'd be great to see the big chemical companies all stand up and shift their focus of material development 100% towards 3D printing, but without sort of, I would say, ubiquity in all the tools in that value chain, it's just going to be really cost prohibitive for them to do that. And now you need to go and do a new material for a new printer, a new company, new print tuning, and you start multiplying. This investment, 10, 15x, trying to get it into everybody's portfolio, and it just becomes a money losing operation very quickly. So I don't know that there's an answer around it for end users other than to really evaluate what does your material and your part need to do, and how can you accomplish that either through design, process, or the material selection.
Well, I think that's pretty interesting that you say that, because I think about the orthotic and prosthetic industry, right? There are some things that just doesn't make sense to 3D print. It's going to be cost prohibitive or something else. But then when you actually take a look at, say, what comes to mind that has done well for us is a dynamic style AFO. It's multi-piece. It can nest well in a build. They're very complicated to make in a traditional fabrication. And while we typically use carbon fiber or some sort of polypropylene or something, we're actually using a combination of a nylon 11 and a nylon 12 multi-jet fusion. And we've had really great results with that because we kind of just stepped back and said, okay, so what is the actual function that we need? And is there a material available? And can we get the price where we need to? And it sounds like that's kind of what you're saying is, find an application where you maybe have a bottleneck, see what's available, and then, hey, maybe take a journey into the additive manufacturing realm.
Yeah, I think, well, I hope that's universally true. I mean, seeing the money, the capital flowing in and out of the industry, I mean, we know that that's not true, right? People chase after cool stuff that doesn't necessarily make sense for their business, and they kind of get burned by it, and you see all these maybe hit pieces about it, which are fair and accurate, but it's kind of like, well, what were you really trying to accomplish there? And I think this notion even of dynamic AFO is like, is this the application that makes sense? Does it solve a real problem? Does it help the end user or the process in some way in making it? And is it differentiated from the old way of doing it? And I'm not convinced. A lot of times when people come and tell us their applications, I'm like, I'm not so sure that this is meaningfully different than the way it was being done before. And when we think about materials in that same light, it's not a surprise that some of our most successful projects in that custom materials program were aerospace and defense, and some of our most difficult were automotive and consumer, because you would have companies that had a lot of capital coming in and doing basically R&D, and you would get to the end and they would realize, well, this isn't economically viable. It's like, we made this bespoke thing for you, and maybe we should have been asking tougher questions up front. And when you get to the end and have tight cost constraints like you do in automotive, you usually didn't come out the other side successfully. And I think we see some of that in O&P as well. And I will always go back to sort of this hierarchy of things that you're solving with additive. The bottom of this hierarchy is something about maybe it saves you a little bit of money, or it helps mitigate some risk for your business, which are important things. And on the other end of that spectrum is really business model innovation or some kind of product portfolio innovation, allowing you to do something you couldn't do before. And if you're not really clear on that on the onset, you probably shouldn't be surprised if you don't get through the other side successfully. And I think that applies to materials, printer, hardware, software, whatever it might be, and across almost every application that you can imagine, whether it's a custom foot orthotic or a DAFO or a helmet. I think it's the same sort of equation.
Yeah, I mean, and speaking of foot orthoses, I mean, that is a very interesting application that seems in the traditional sense to have a lot of waste. I mean, it makes and you can pack a lot of those into a build volume. I mean, what were some of the considerations as the Arise team was looking at some of this stuff and coming down into that foot orthosis realm of like, hey, this is going to make sense in multi-jet fusion, and here are the reasons why.
Yeah, I mean, specifically the technology fit, that one's maybe easier. I think the business fit's a little more difficult and more unique with the Arise solution that HP had launched. Technically speaking, MJF really lends itself to high repeatability, high volume, and good enough surface quality. So if you're burning a lot of cycles, having to finish and do special things to the part after it comes out of the printer, well, you're kind of back to the same problem you had before, where you still had a technician sitting there doing those things anyway. So when you kind of mix together, material performance that allows you to do something with the design that you can't do with other materials, the process and the throughput, the accuracy, surface finish, and then the removal of steps from the traditional manufacturing process that can either help you, if you're a lab, to maybe rethink your labor problems. There is a labor shortage that I think everybody's aware of, or you're now offering some innovative product that sets you apart from your competitors. I think it's really that combination of things. It's not any one thing that really helped Arise to grow as quickly as it did.
Yeah, I think that's an interesting take, and it sounds like it really is not just the printing that was the solution, right? Because it does lend itself to the volume, but it was really the back end considerations. So you've got labor, software, automation, that sort of thing. How do you leverage all that together? And what would you tell people? Because we have, there's a lot of listeners from the O&P industry of they are wanting to look into the 3D printing side of things, but they struggle, say, in the design or application or what have you. Where do you say they start? Because it sounds like it's a combination of multiple things, and it's not just the printer.
It's definitely not just the printer. And touching on Arise for a moment, and then I'll try to remember your question. But the workflow and the sort of end-to-end process being improved for both the clinician and the patient was really the key there. And, we found a lot of success in podiatry where the podiatrists are relying on these labs to turn around and order, which, by the way, they filled out probably by hand on a piece of paper and faxed it over, right? And they were finding that they were losing control of what was coming out the other side, and it was letting their patients down. So you saw high return rates, high turnaround times, and a lot of disappointed patients. And I say a lot, meaning a couple percent, right? It's not like hundreds of thousands of people. And the printer is almost the least important part in that example. What's way more important is the confidence, the throughput and predictability of their business, and then of course delighting their patients. And I think the same is going to be true, or is true, across a variety of applications and sort of devices that are in the industry. And I think for those trying to evaluate, does 3D make sense for me? Does it make sense for my business? I mean, it really depends on where you are in that value chain. And my sort of overriding criteria is that the value created has to match or be close to the value that's being captured. And what I mean by that, if you're just using 3D printers because you think it's like this cool thing that can make your practice look better to your patients, okay, that might be true. But if you don't have a meaningful source of value creation there, your patients are going to figure that out. And if they're not having either the same or better outcomes, you're probably going to struggle in the long term there. And I think it's hard to say, well, how do you get into 3D printing? How do you take that first step? But I think education is probably the first piece. And when I think about orthotists, prosthetists, and again, definitely not a clinician, but I've talked to hundreds of them. There is sort of this fear of change, fear of a new thing, which I think is very normal human emotion, right? Anytime we're going through change, it can be uncomfortable. And think about their training and upbringing and the notion that you have this really unique source of value where you have a human relationship with somebody who's coming to you to have some part of their life, changed or improved or restored or whatever it might be. And this person is also a maker. They make stuff with their hands. They create something from raw materials. And so now you introduce 3D printing, and a lot of times the gut reaction is, well, that's invalidating part of my value creation. And I think you could look at it that way, but the reality is, as you learn more about it and you start to understand how it actually could amplify your skills and the way that you create value, I think people come around very quickly. And then the next question is always, well, how do I get a design and how do I get it into a printer, right? And that's kind of a whole other problem to solve.
Yeah, no, and I think that's interesting, and I love that of your take, because there is a very much a human element to providing a prosthesis, orthosis, even down to foot orthoses, that you don't have in the automotive defense. Those stuff goes on rockets,
Mm-hmm.
they go on cars. The cars don't necessarily talk back if they don't like them, that sort of thing. And there's also, I would say, less time constraints because that stuff can get into a rhythm. So, for example, we're at the end of the year here, and most people's deductible roll over January 1. Well, we are working like crazy to try to make sure that we get devices out to patients as quickly as possible so we can get them to, before the end of the year. And while there may be some cases there, I think, like, even down to contract manufacturers and such, they don't understand the urgency of some of these things. And I think that's one of the struggles that I've had with even outsourcing some things is, sometimes things need to be reprinted or what have you, and there's just no communication. And what's really happening is we're keeping a patient from walking another week or something to that. And there's just that human on the other side. And I think if the contract manufacturers knew that, there would be a sense of urgency. But there's some education that has to be, in all that. And that's what makes O&P interesting. I think the other thing that makes O&P interesting, though, is that most companies can't go out and buy, a big time machine. And in fact, I don't suggest it, but, focusing on those inputs, like what you were saying earlier, is super important. So, all that to say is that when somebody is looking, so we had Lee Dockstetter on a couple weeks ago, and one of the things that he was saying was around this idea of productization of this. So it's custom, but it's also kind of for the masses. When you're looking at O&P and some of our devices, I mean, what do you think about that aspect of, say, the design then to the print? Do you really look at how do we create a product from this and make it repeatable, and that's when it starts making sense?
Well, I think it will always make sense when it solves a real problem. And you can be flexible about what that problem is. But if you're not solving a real problem, then it will likely never make sense in the long run. And I think, O&P is unique in that it is by definition 100% custom. And you can have off the shelf stuff, and that's fine. I kind of think of that differently. And so for additive companies, contract manufacturers, service bureaus, they kind of look at it and think, oh my God, this is such a great opportunity. It fits our technology so perfectly. But the tools and the workflow are paramount. And you're right, these contract manufacturers are not often realizing there's a human being on the other side of that product that's waiting to receive something that they need to live their life as normally as possible. And the reality of additive, and I think where the tools and the workflow need to come in and be a little stronger, is to help double down on getting that patient back to whatever they were trying to do as quickly as possible. I mean, that's where the success of Arise came in. And I think that's where the success of a lot of these companies that are popping up in O&P is coming in. And I think long term, the productization, I'm a little less hot about. I think there's a lot of ways to sort of go after that. But if you can put that human being on the other side at the top of that sort of value pyramid or whatever hierarchy needs, whatever you want to call it, I think you'll find success as long as it solves the real problem and doesn't put undue friction in that workflow or that value chain. And I think, to your point, one of the biggest problems that clinicians especially are struggling with is the digitization. And take that however you will, whether it's digitization of the anatomy capture or the design process or the output. I think one of the things Lee actually said that I totally agree with is you have to automate that middle piece of it no matter what. And you see a lot of companies coming in with really nice software tools, really great UI, simple to use design tools, wonderful. Scanning is becoming pretty ubiquitous, tons of options in scanning. The interoperability of those is getting almost foolproof at this point, but all of them are going to need to automate that step between create design and print design. And if you can't do that, I don't think you're going to succeed no matter what the product is within reason. I think there are products in the industry that are of such high value that you might be able to get away with it. But when you look at, maybe more simple products or products that are kind of on the bubble of custom and does somebody really need this? And is it really solving a big problem for them? That gets a little more difficult to justify. And I start thinking about, well, what else could it be helping with? And I think that the foot orthosis is a great example where, you're solving a real problem, but what we heard time and time again, and I think the real value that additive can bring to clinicians especially, is it gave them a lot of time back. And so if you're spending, 10 minutes less doing anatomy capture or 10 minutes less doing design or dealing with the logistics of fulfilling that part, that's 10 more minutes you have to spend with that patient, right? And that's kind of an immeasurable thing that we heard time and time again from our customers. And I think that could be one of the more fruitful areas for additive to unlock the time of the clinician.
Yeah, I mean, I love that you say that. And you actually just confirmed what Lee told me. He said, Brent, I love what the stuff that you're doing, but guess what? What you're doing is not scalable.
He's right.
kind of hurt my feelings, Ben. But what's interesting is we had that conversation a while back, and I've now even after talking with you and Nate and some others of like, okay, so how does the clinician become the clinician? I look through even some of the stuff, the history of some of the stuff that I've put out on either social media, and it's always like, how do you hand make this device, and how does the software work? And the reality is, at least my interactions, and you've had probably way more interactions than I have with clinicians, is they don't really care how it's made. They want to take care of the shape, and they want the end product, and whatever happens in between, they're I shouldn't say all of them, but most of them just want the product. And then the ones that want to tinker are the ones that want to tinker, and I think you're gonna have those anywhere. But what's interesting is that this new generation of clinicians that's coming out, they value their time immensely. And I love that about them. But what that also means is they have zero tolerance for staying to the lab till 1:00 in the morning to make sure their plaster models are finished. So the technician can take care of it the next day. And I really think that's going to be what's going to push forward. But I'm just curious, like, in your interactions with clinicians, what are you seeing? And are you seeing a trend in the way of thoughts around that idea of we don't really care what happens in the middle. We want to do our clinical thing, and we also want to fit our thing.
Yeah. Yes. Now there's a spectrum of people and their experiences and what they care about. And one of the unique things about helping the Arise team is we started in podiatry and expanded and broader into O&P. And so we saw this really wide range of people and clinicians and what things they valued. And you can kind of associate it with their training and a little bit of where they live and where they're from. But that emphasis on value absolutely changed through that spectrum. And in podiatry, it's not so much about time, but for an orthotist or prosthetist, especially the younger ones that are like fresh out of school, they care immensely about their time, and they do not care, to your point, about how something is made. Now, of course, there are people with different thoughts and different sort of opinions on this matter. And you'll always get the reservation whenever you see some new technology come in of, well, is this good enough, right? And there's been kind of a lot of buzz lately about, is 3D printing acceptable for sockets, right? And I think people get lost in sort of the tech specs and the feeds and the speeds and the test data of this one versus that one. And really, they should be focused on what's more important here is these are clinicians who are vetting new technology because it has to go on a human body, right? And they might not care about how it's made, but they care that it's made to a degree of quality and consistency that they trust enough to put it on a human being, right? And then if it's made in a way that gives them time back or keeps them out of the shop until 1 a.m, they are 100% going to sign up for that. And that's kind of my point about, I think education is really important, especially in the clinician level. Understanding like your source of value is going to shift much more towards your time and your time with that other human being rather than your ability to make something with your hands, necessarily. And I think that what you described is holding up to be true. And, there are trends of how people are valuing their time and what they really want from things. And maybe I'll add two more thoughts on this. But one thing that we've noticed, on the patient side, I'm really curious what you think here, but on the patient side, it seems people are becoming more accustomed to general consumer trends. I can go on Amazon and get something tomorrow, sometimes today, and now I'm going to go to my orthotist and he's going to make me a custom foot orthosis and he's going to say, come back in 6 weeks. It's like, what are you talking about? I can go order something on Amazon like in 4-hour delivery. Time is super critical. On the other side of it with the clinicians, people just want stuff to work. They don't want to sit and fiddle with it, and they don't want to play with all the buttons. I mean, within reason, some people do, but the majority of people don't want to sit and fiddle with stuff. They just want it to work, right? So if you can give somebody's time back and you can do it in a way that's super simple, easy, and intuitive, that's going to be a winning solution no matter what it is.
Yeah, no, I love that. When it comes to foot orthoses, I know that was the case because the labs took that long and that sort of thing. I'm running into a little bit of the opposite actually, where some of these clinicians that I work with they're very talented. They have people literally come from not only all over the United States, but a lot of times all over the world. And one of the things that they say is 3D printing is just not fast enough compared to traditional manufacturing. Well, that is kind of true, so
kind of.
So, and this is the conversation that I have with them. It's like, okay, so maybe the person that comes in from out of the country, it's not the right fit, and you've got to, have your technicians and you work, all that stuff. But what if you were able to get into a rhythm? Say you had your patient come in on a Monday, and the following Monday that you fit them, and you literally you do new fabrication, and it opens you up to see those patients that come from out of the country, and then you don't have as long a day there. And whether that's the right model or what have you is, kind of irrelevant, but it's interesting to me is they will put the kibosh on 3D printing because they can quote unquote make it faster or the same day, which is true, but is it efficient and the best use of time? Probably not. And maybe then it's like, okay, so you have that discussion of how do you incorporate the right solutions in? And I had a funny conversation recently with a friend of mine, and he was talking about a company that he worked with. He's like, they're not wanting to 3D print anything, but he said they don't want to 3D print anything, but they will literally let me take a piece of plastic that they don't know where it came from or how long it's been on the shelf, pull it out of the shelf, put it in the oven, and vacuum form it over a model by hand, but that's okay. He's like, 3D printing makes so much sense because it's going to be very, very consistent every single time. You don't have somebody's hand in there, and then let alone a hand that is super valuable like a clinician's hand. So I think that was an interesting take as well. But I don't know where to go with that. I mean, that's just the story that I have. But it's so important to know the why. And and the other part was I used to be that person, and that's the crazy part. I don't know if you knew that or not. Like, I thought that if you took a scan of a patient and you carved it or 3D printed it, that you were less of a clinician, like because you didn't actually put your hands on the patient, right? And boy, have times have changed, and I actually feel the exact opposite now. Is if you don't think digital first, not only for just records, but also then for fabrication, especially with the outcomes that we're having. I mean, this may sound harsh, but I think you're less of a clinician just because you're not putting the tool in your toolbox. It might not be the right application, but if you have closed yourself off enough to where you won't even consider putting the tool in the toolbox, to me, that's a problem.
Yeah, I agree, and that's kind of what I'm getting at with the source of value creation is shifting, and it is an uncomfortable thing for somebody to suddenly feel invalidated. But I would argue, and I think you went through this process and this change process yourself, right? Your source of value as a clinician is not as much about what you can make with your hands. And there's a lot of ways to say this, whether it's opportunity costs or how you spend your time, or thinking about what's the most valuable thing I could do that nobody else could do, right? It's all sort of the same topic. And I would suggest very politely to clinicians who are feeling like their value is making stuff that, they should be, and I'm going to steal a quote from somebody and probably butcher it, but like super disciplined and hyper-focused on the vision, right? And really flexible about the tactics and how you get and accomplish that vision. And the vision for the clinician should be the improvement, restoration, or however you want to say it, the improvement, restoration of a human being's life, right? And whether you're using a carver, you're thermoforming, or you're, making it out of plaster of Paris and carving it with your hand, I don't know, right? It shouldn't matter as much how you get to that thing that achieves your vision. The vision needs to remain the patient care and the patient outcome. And I think as long as you're rooted in that, you can kind of convince yourself that maybe your ability to pull a socket over a form is not necessarily that important.
Yeah, 100%. And I think that's what's neat about the schools is I think they're showing people the hand skills side of things, because it is important to be able to these devices, whether you 3D print them or regularly make them, you still need to have hand skills to make adjustments, and there's going to be adjustments made to these things. So I appreciate that side of the hand skills, but then also like, hey, you need to get super comfortable on communicating what you need.
Yeah, and I think not only that, but caring for that other person that you're working with, and understanding and being able to communicate with them. What is this process, and how are you going to do something for them? And I think the hand skills are important. They're important, as is sort of testing and the deliberation about specs and what is the strength and cycling and all this kind of stuff. But the reality is there's never going to be one thing that solves everything, right? And so if people are having this mindset that 3D printing is going to replace or invalidate my skills with my hands, or it's not going to be this perfect like million cycle socket, I think that's a little bit short-sighted, and we just kind of need to realize there's going to be a place and a need for you to have skills with your hands, making adjustments. And sometimes you're probably going to have patients with unique circumstances who come in and they need something tomorrow, right? And I'll never forget a conversation I had with a podiatrist at a conference. And, we had a 10-day turnaround, fully custom for orthosis, like meaningfully different than labs in the industry. And I remember talking to this guy and I said, look, we could probably do it in a week, like on average for you if you really need. And he said, no, I can just go to my neighbor's house and he'll make it for me the next day. And it's like, okay, that will probably always be true. And maybe this isn't for you, but the reality is there are cases where you're going to want 3D, you're going to want additive, and there are cases where you're going to want to make it by hand. And I think your example of you've got a patient that's either remote or out of the country or whatever, and they can only be there for the weekend or for a couple of days. That's really meaningful to be able to sit there and make something by hand. Now, the other 90% of your patients or 98% of your patients, maybe you can go additive with them.
Yeah, I really like that. So, through all your conversations, how would you suggest people start on their additive journey? I mean, I know that at least the last numbers that I saw is like over 50% of clinicians are scanning, and that's and that's a start, right? Is you got to scan. It falls off quite quickly of what happens to the scan after that. Yeah. But so let's say, well, let's do two things of, somebody's not scanning, where to start. Somebody is scanning, where to start. And then let's just go one step further. Somebody is scanning and doing maybe some FDM stuff. What's the springboard for those kind of three people?
Yeah, that's a tough one. The person that's not scanning, I don't know if they're paying attention, but we live in a world where you have most phones have some kind of true depth or LiDAR type sensor. You can scan almost anything with basically free apps, right? And you send that scan wherever, scan it for fun, whatever you want to do. That's probably the easiest thing, just getting comfortable, understanding how does the technology work and how accurate is it. There are a ton of good and lower cost scanners on the market. I think scanning has become ubiquitous. It's almost commodity at this point. And they have a lot of different formats and ways to integrate with, whether it's getting a file that you send to somebody, or maybe your lab, or you work with a lab, or you work with a major OEM that can take that file and do something with it. That's true right now. And then there's sort of the, I'm good at scanning now, what do I do? I think you either look for a partner that can take in that scan, and there's tons of good companies out there that can do this. Or to your point, maybe you buy kind of a cheaper FDM printer and you play around with it. I think I want to be careful not to get into the realm too much of like the 3D printing nerd, so to speak, of which I am one and many of my friends are, but buying a low-cost FDM printer and playing around with it can be an illuminating experience for people. And you can realize very quickly, yeah, this might not be that amazing of a printer, but the ability to get through that workflow and scan, put it onto your computer as simple as possible, slice it up and send it to the printer, that can be the easiest way to start for really low amount of money to just start getting comfortable with the process. Now, my hope is, and I think what we've seen a lot in terms of investments in new startups, people are building tools that make this really easy. And the reason I say education is really important is I think it's more valuable to understand the process and what you need it to do, so that when these companies start entering the market a little more quickly, you can better evaluate what they have to offer and how it fits with your needs. But I think if you're just getting started, go and try some stuff and play around and join webinars and learn from people that have done it before. Follow you. I mean, you're like one of the best resources I've seen in the industry, and there are a ton of people like you. And I think just try to learn as much as you can and dip your toes in, low cost, low effort. Just try it out.
Yeah, and I love your idea of the low cost FDM stuff. I always say getting a printer is the second thing you should do. It shouldn't be the first, but sometimes getting it first and then realizing, oh, I'm tired of printing things off a Thingiverse, maybe I should learn how to design, is an important illuminating experience. And then being like, Oh, I cannot get what I have in my head to the printer. That's another illuminating experience.
Yes.
And I think it's an important one to have, because the reality is, and this is where I struggle a lot, on, communicating. Like, people see the stuff and they're like, "Oh, Brent, that is so cool. I'd love to do that, but I'm just not able to, so I'm not going to do anything."
Yeah.
I have that conversation a lot. It's like, well, guess what? When I started, I wasn't able to do what I'm able to do today. You've got to start somewhere, or work with somebody that is doing the stuff that you like. And there are other availabilities other than us at Advanced 3D, and that's a great way to get going. But that this idea of, oh, that's too hard, I'm not going to do it, that's a tough one.
Yeah, and it's a really easy excuse. I mean, I suffer from the same thing in my personal life, and not to call everybody out, but like that's a lame excuse. And you probably heard the saying, like, the best way to get something done is to just start. I think that's true of adopting new technologies just as much as it is, like, cleaning the garage or taking out the trash. Like, you just need to start and realize it's going to be difficult and it's going to be uncomfortable, and that is the process of learning and growth. And if you don't want to do it alone, there are a ton of great companies out there. I mean, you mentioned one. There are, I don't know, 10, 15 others just like them that can happily help you. And they may not be like this amazing expert that will sit down with you 30 minutes a night like a private tutor, but they can probably help you with the immediate problems that you're going to have. But at the end of the day, you just got to start. You just got to try and go through that learning process and treat it like anything else in your personal development, where you're going to do something new and it's going to be uncomfortable, and that's the nature of the beast.
Oh, that's good. Yeah, do something uncomfortable. Well, we've covered a lot today, Ben, and there's a lot that we haven't covered. Do you feel like we've got some big glaring gap that you specifically may have something to speak into, or do you feel like we've done a pretty good job covering stuff?
We being you and me, or
yeah,
we being
you and I.
Yeah, I think we've covered a good amount. I am curious, always curious to hear your take on a lot of things. And I guess one thing that I've seen a lot of noise around lately, and I have an opinion, but I really want to hear yours, is this idea of test specs and specifications and strength requirements around finished devices, and where you think the role of having test specifications and strength or modulus or elongation requirements or guidance, if you will, on, let's say, definitive sockets. Like, what's your take on that?
So, man, I thought you were going to give me an easy one, Ben. This is a tough one.
No.
So, a couple things. One is, that comes first to mind, and it's not, this is not a flippant type of thing, but there is no testing that happens on traditionally fabricated sockets. And so that, to me, one of the lamer excuses, or more lame excuses, is, well, there's just no data on 3D printed sockets. And the truth is there's more data on 3D printed sockets than traditionally fabricated sockets. And a traditionally fabricated socket at my facility is going to look so much different than Jerry and John's clinic down the street. And so there's variability in that. There's variability in resins, humidity, how much hardener you use, all that stuff. And so there's just an overall lack of consistency in traditional fabrication. And this idea that traditional fabrication doesn't fail is hilarious to me, because there is no clinician that is going to stand up and say that they've never had anything that they fabricated fail. So that's my take on that side. Now, on the, is it important for testing? What we don't want is, we want thoughtful designs coming into the market, because people can ruin this fairly quickly. With the wrong things getting out there, and so, like, things like the hammer test, or putting things in a vise and bending them out sideways in an area that's not going to take pressure. While it's an interesting concept, and I think the idea behind it is good, it's not truly reflecting of reality. So rarely has a socket that I've fit, and I can't think of one, I've been doing this almost 30 years, fail because of regular walking. Just somebody's walking and it just boom, broke, nothing happened. It's always like, oh, I was, walking on ice and I fell hard. Or, I mean, we had a case where a prosthesis came and it was cracked, and it was just cracked in a very unusual spot. And so as you start diving in a little bit, it's like, oh, yeah, my neighbor is in a power wheelchair and ran over my prosthesis. So that's always like an event, and that stuff is hard to test. Now, I also get the idea of, you want to make sure that a prosthesis is not only safe for a patient, but that if they're out somewhere, that they can get home. And I think that's a goal for traditional fabrication and for 3D printing. However, you're going to have cases in both spectrums where the patient's not going to get home and something has failed. There's so many variables that go into that. So a lot of people, point to the ISO 10328 standards, I think, which is a great baseline of where to go. And then, believe it or not, I mean, as far as I know from what I've read and fallen asleep to that document multiple times, is there's not necessarily standards for sockets. So everything is an interpolated, I'm going to use this standard and we're going to do this. But like for cyclical testing, there's nothing that says this is how you do cyclical testing on a socket. Some people have made some stuff up. And so I think that's the difficult part. One of the things that I think I feel good about on the way that we did things, and I think it helped us get ahead of the curve, is, as a small company, we did the initial testing for the ISO 10328 for the foot and ankle components, and we used that kind of idea on the destructive testing side of things, whether our sockets were strong enough to move towards cyclical testing. And then once we did that, and actually, this is a funny story. I don't know if you've heard this one. So when we were doing our testing for the destructive testing of sockets, so it was in an Instron machine, and you have a 20-degree shank angle and a vertical force straight down, and there's a mandrel that goes inside the socket. Well, around 3,000 pounds of vertical force, which is 2x the ISO standards, the mandrel actually fell out of the socket because the socket had deformed enough and just let the mandrel out. So the socket actually never failed, and that happened multiple times. So when that happened, we felt very, very confident and comfortable that we could put these on patients. And I put these sockets on patients that I knew very well, that were local to me, that enjoy trying new things.
Yeah, Brent, I'm betting that experience is not unique for you. As being my guest. If we've got time, can I ask you one more unfair question? Okay.
Yeah.
So I don't know what the real number is, right? But we think that custom devices are roughly 5 to 10% 3D right now in the industry, of which, by the way, about half are MJF, half or more. What do you think? Or maybe if you could rank these things that I've heard people say are really important, what do you think are the most important things to drive those adoption numbers up, between process automation, design validation before printing, reimbursement for 3D printed devices, or just general improvement of tools like software, hardware, materials?
Yeah. So I think the biggest, so scanning is the big one. And then I think the design side is the second part. And I still think the clinicians should fit their test sockets, and I think they should 3D print them in the clinic. I don't think they should send those out. So I don't care where they have them designed. In fact, there's a couple of very novel places that will actually do the design and then throw them on your printer in your facility for you, and then you just take them off. And I love that model. And I think that there's a lot of value to that. So it lets the clinicians be the clinicians. When it comes to the multi-jet fusion side of things, I think what bothers me the most is software companies creating sockets that may look pretty or are together, meaning like there's a socket connected to a distal adapter, but they really have no idea on what they've done, and I believe that's a problem. So I think that what happens in this, at least, and obviously I'm biased because of the stuff that we're doing, I think that inner surface, that connects with the patient, is the most important thing. That is the gold. The second piece is the alignment piece. So how does that interact with the floor? Those are all clinical decisions that are made on site. If those two decisions made by the clinician are captured digitally, the rest can be 100% automated. And actually we're doing that right now. And that is what's going to drive the price down to where it's actually going to make more sense to even contract manufacture some of these sockets out rather than traditionally fabric in-house or out-of-house, because the pricing is going to be so good, because you now have let the clinicians do their clinical things and the people that are experts in the printing do their things, and then you have the outcome coming out the backside. So that's my opinion. But along that same line is not all contract manufacturers are made the same. There are a lot of contract manufacturers that will push the boundaries of what is possible in density, powder quality, orientation, all those things. And just know that as a clinician, sometimes getting it at the best price does not mean that you're going to get the best product back. So you want to have that conversation with those contract manufacturers.
And do you think this is a really interesting point that you're making here about contract manufacturers? You're right; they're all different. They have their own criteria that may not be aligned with the clinician. Could you foresee a role for some? I don't know if it's an OEM or some industry association to come in and say, look, this is what good looks like, and don't cut corners if you can't achieve this good, and almost sort of validate contract manufacturers so that the clinicians aren't wasting their time sort of testing and investigating the contract manufacturer. I mean, do you think there's a role for that?
I would love that to be the case. I would say at least my interactions with and I know that it's me, and but my interactions have been with contract manufacturers is that they're not interested in that kind of feedback, at least right at this time. Maybe it's changed. It's been a little while since I've approached it, but I do feel like that is something in any powder bed fusion technology. And while we're on the powder bed fusion, I mean, I love to hear that HP is more than that. I mean, we have testing on all the technologies out there. A lot of people would love to see that, and there's a reason why we did multi-jet fusion technology. One of the main ones is watertight, airtight right off the bat, but then the other ones are dimensional accuracy, the powder handling, and all that stuff that goes along with it. Of course, you've got your headaches that come along with any technology, but it's definitely, to me, been the best technology, most consistent technology along the way. And so I think that's the other part of the clinical side of things, is that spending your own time to try to jump into some of this is super valuable. And a lot of times, it's as crazy as it sounds, people try to stroke a check out of their problems. So like, I was actually just talking to a company, it's been a couple weeks. They were getting ready to buy a machine. And I said, well, do you have anybody that's scanning? Well, no. Do you have anybody that's designing? Well, no. I'm like, well, maybe you should look at that. The other part that's interesting, and I actually had this conversation with a very large online portal place, is there is a ton of capacity in the United States on machines, unused capacity. Not saying that these people aren't profitable. It's just unused capacity. So machines are running where there is space, essentially. And so one of the things that I think that is interesting is the reality is a lot of the magic happens in the post-processing. So to me, and that's where a lot of the cost, for vapor polishing, there's a cost every time you push the button, whatever.
Mm-hmm.
If you're able to control your post-processing, you will actually get faster parts. So what that means is, say if I have a multi-jet fusion machine, we'll just say me, and I don't have a 5200. I wish I did. But so if I had a 5200, the reality is I could put your parts in today and be harvesting them tomorrow. Now I have to harvest them. I have to post-process them, and we'll tag on a day or two extra for that, or it's going to be some wicked, expediting fee. But if I was to approach a contract manufacturer and say, hey, I have blasting, I have my painting or post-processing taken care of, I just literally want you to pull my part out, knock it off, make sure there's no defects in it, and throw it in a bag. If there's powder all over the place, I don't care. I'm going to take care of it. You're going to get something faster, and you're going to control the output there. And so I definitely see that as an option, a very reasonable option for people, because that post-processing equipment covers a whole bunch of different technologies, whether it's TPU, multi-jet fusion, PA11, PA12, even FDM stuff you can post-process with vapor polishing and that sort of thing. So to me, having that tool in-house and not having to rely on anybody is super important. And then let the other people buy the $500,000, $750,000 machines and take advantage of the excess capacity.
That's a really, really interesting approach. I would totally agree with that. And that, I kind of cringe when people tell me that they're buying a $500,000 industrial printer for their clinic. And I'm like, okay, do you have a workflow in place, or are you just going to make a bad decision here? I know a guy that can help you with that 5200. But it's kind of, I appreciate hearing your preference for MJF as a technology. However, the workflow is executed. And you might not believe this, but I swear this is 100% true. I chose HP for my career, right? I left Stratasys on purpose and chose HP. And it's because we were doing competitive testing on their parts before they had launched their product. And I remember thinking, oh my God, this is the technology of the future. This is going to be the one. So I think it's showing itself to be true, especially in real meaningful applications like in O&P. So I'm glad that you agree about MJF being cool.
Yeah. Well, awesome, Ben. Thanks so much for being on the show today. Joris is visiting his parents. He was on at the beginning, but apparently his internet, he just texted me. He said, dude, my internet is so terrible in the Netherlands. So he said, sign off for me. So thanks, Ben, for your time. This is great. And I think a lot of people are going to get a lot from this podcast.
I sure hope so. Really, really grateful that I could sit down and talk with you. And if I could shamelessly plug, I think you should have Nate on. I think he would have very interesting perspective for your listeners.
I think that's a good shameless plug, and we'll have to make that happen. I think I know a guy, right?
Yeah, you might. Yeah. I might sit next to him and have the ability to throw stuff at him. So
perfect. Well, and thank you all for listening to the Prosthetics and Orthotics podcast. Have a great day.